When we talk about traveling through space, there is always one huge and impossible to avoid problem that we must solve. It is having enough energy, or basically the right kind of fuel, to reach the place we want to go. Every science fiction story uses some made-up idea to skip this energy problem, like warp cores or hyperdrives. Hyperdrives, very fast imaginary engines. But that is why we call it science fiction. None of these things exist in the real world today. And while new discoveries could change everything, they are not coming soon in our lifetime. But that does not mean we will never see a spacecraft travel between the stars in our galaxy. It just means we need to find a new way to power those spacecraft. And the best place to start looking is deep in our own history. For most of human life, we traveled by boat using wooden oars. Oars, long sticks used to row, powered by people, or cloth sails driven by the wind. Sailing ships carried no fuel, yet they crossed very large distances by using the forces of nature. Even today, sailboats move smoothly across lakes and oceans without engines, guided only by the movement of air. Now, what if we could use the same idea in space? Before we answer that, let us look closer at how sailing really works. The forces that push boats through water might show something surprising about moving in space beyond Earth. Ask yourself this question: what moves a sailboat? The answer seems clear, right? It is the wind. But where does wind really come from? You see, wind is caused by differences in temperature. Some parts of Earth heat up while others stay in shadow. Hot air gets bigger and rises, while cold, heavy air moves in to fill the empty space. This movement creates the wind. And at the center of this whole process is the sun, the main power for all weather and nature on Earth. So in a very real way, sailboats are actually powered by the sun. For thousands of years, sails helped people cross the great oceans. But even the longest sea trips are nothing compared to the endless empty space beyond our planet. The ocean is large, but space has no end. It is a pure vacuum. Vacuum, complete emptiness with no air, where nothing pushes, pulls, or moves without a reason. So, how do we move through it in a good way? Our current rockets are simply too slow and waste too much fuel to reach the stars. The Apollo missions, the space shuttle, and today's SpaceX flights all use chemical fuel. They burn huge amounts of propellant, rocket fuel, just to escape Earth's gravity. Even reaching our closest planets is very hard with chemical rockets. Scientists have looked at new ways to make space travel faster, like nuclear propulsion, using atomic power, ion drives, and even antimatter engines. Each one shows promise, but each has big problems. They need too much fuel, they are not efficient enough, or the science is not ready to take us to another star. Proxima Centauri. Closest star system to us, the nearest star system, is only 4 light years away. But with today's rockets, that distance feels like forever. So if normal rocket engines will not get us there, then what will? Among modern systems, ion drives are the ones that use the least fuel. They use electricity to create thrust, pushing force, letting spacecraft speed up slowly over time. With enough fuel, an ion-powered ship could finally reach very high speeds, much faster than chemical rockets. But there is a problem. Xenon, a heavy gas. The gas needed to make the ions is hard to get in large amounts. We simply cannot carry enough of it to get the speed needed for the huge distance between stars. The Parker Solar Probe holds the record as the fastest spacecraft ever, reaching over 690,000 kilometers per hour as it moves toward the sun. But for ships going away from the sun into deep space, Voyager 1 is still the fastest at about 61,000 kilometers per hour. At that speed, reaching Proxima Centauri would take more than 17,000 years. So a probe sent today would not send back useful data for another 350 centuries, hundreds of years. If rockets cannot take us to the stars, then what will? The answer is not more fuel or bigger engines. It is something completely different. Something that needs no fuel at all, like sailboats powered by the sun. Could we do the same with a spacecraft? Well, we already have. The technology is called a solar sail. It is driven not by engines, but by the gentle pressure of light, the same way a kite is pushed by wind. The sun sends out photons, tiny particles of light. These have no mass, yet they carry energy and momentum, force of movement. This means they push when they hit a surface. When they hit a very shiny solar sail, they do not just disappear or bounce away without order. Instead, they give some of their momentum to the sail, pushing it forward little by little. Unlike chemical rockets, solar sails do not burn fuel. They use the never-ending flow of photons and sunlight. Though the push at first is weak, it never stops. This constant push lets the spacecraft slowly reach very high speeds over time, far more than normal engines can do. Solar sails must be extremely light, very strong, and highly reflective. Reflective, shiny, sends light back. Because if they absorb light, it will not create thrust. It would only heat the sail and waste energy instead of turning it into movement. Steering is done by changing the angle of the sail, like a sailboat turning into the wind. So light is not just the engine. It is also the rudder, part that steers, the compass, and the fuel. It pushes the sail forward and gives exact control over the path. And this is not science fiction. In May 2010, Japan's space agency JAXA sent Icarus, a solar sail spacecraft that worked without any fuel. Icarus reached speeds of thousands of kilometers per hour. It flew past Venus and kept sending data for 5 years. With help from Venus's gravity, Icarus reached a top speed of 12,000 kilometers per hour. If given more time, it could have gone even faster than Voyager's 60,000 kilometers per hour. In June 2019, the Planetary Society's LightSail 2 used only sunlight to change its orbit around Earth. This proved that controlled steering with solar sails really works. And in September 2024, NASA launched a CS-3. It successfully opened its 9-meter-wide solar sail. The push was small, but clear and measurable. However, one of the support booms, long arms that hold the sail, bent, causing some problems. But the spacecraft still sends useful data. These missions show that solar sails work. But to reach the stars, sunlight alone might not be enough. We may need something extra, a stronger push. We can give solar sails that extra push with powerful lasers from Earth. Project Breakthrough Starshot, started in 2016 by Yuri Milner, Stephen Hawking, and Mark Zuckerberg, wants to push tiny solar sails to 20% of the speed of light. That is fast enough to reach Proxima Centauri in just 20 years, instead of 350 centuries. The big challenge is cost. Building Starshot would probably need billions of dollars. While we could use only the sun to move us, lasers from outside really make the big difference. Lasers in space could work, but they would never be as strong as laser systems on Earth, which can make almost unlimited power. The idea is simple. Shoot a powerful laser at the sail, and the photons push it forward just like sunlight. But unlike the sun, a laser can focus huge energy on a very small area. This speeds up the sail much faster than natural starlight ever could. The laser system itself must be very large, maybe kilometers wide. But it is not dangerous unless something like a bird or plane flies through the beam. Since space is mostly empty, there is little risk of harm outside our air. So, let us imagine we build this ship. Once a solar sail leaves our solar system, steering becomes much harder. Light gets weaker quickly as you move away from the source. So most of the speeding up must happen early. This means we need very exact aiming before it reaches deep space. Once the solar sail reaches the target star system, slowing down is easy an idea. By turning the sail to face away from the light of the new star, The same light pressure that pushed it forward can now act as a brake. But if we get all this right, if a solar sailing ship can cross the great empty space between stars in our galaxy, then what? What do we do with that ability? Again, we can look at history. As soon as people proved a boat could sail west across the Atlantic Ocean and find new land, a new time of exploration started. People are pulled to the unknown. It calls to us, and humans will always answer. But we must think big. A solar sail ship big enough for humans would need a huge sail, kilometers wide. It could only be built and put together in space. The ship would need heavy protection from radiation. Radiation, dangerous rays in space. No gravity for so long would cause serious health problems. Life support systems would have to be very reliable and able to keep going on their own. If humans go, a sail powered only by the sun probably would not be enough. Laser push would almost surely be needed to reach the right speeds. But the main idea is good. Solar sails need no fuel, can reach very high speeds, and could be our way to the stars. The only thing stopping us is the will to build and fly them.